Wheat, particularly in the form of flour, deserves a much deeper and more nuanced discussion because it sits at the crossroads between traditional nourishment and modern ultra-processed food systems. In its original state, wheat is a resilient cereal grain that evolved to store energy efficiently while protecting that energy with layers of fiber, micronutrients, and bioactive compounds. The bran contains insoluble fiber, minerals such as magnesium and zinc, and antioxidant phenolics that support gut motility and reduce oxidative stress. The germ provides B vitamins, vitamin E, healthy fats, and plant compounds that support cellular metabolism and nervous system function. When wheat is eaten in this intact or minimally processed form, it contributes to sustained energy release, better appetite regulation, and long-term metabolic stability. The transformation toward ultra-processing begins the moment wheat is milled into refined flour. Wheat is uniquely easy to refine compared with many other grains because its anatomical structure allows the bran and germ to be mechanically separated with high precision. Modern roller milling does this extremely efficiently, producing fine white flour that is almost entirely endosperm, meaning mostly starch with a small amount of protein. From a nutritional standpoint, this removes the very components that slow digestion and nourish the gut microbiome. From an industrial standpoint, however, this refinement is ideal because it creates a shelf-stable, uniform ingredient that behaves the same way every time it is used. Refined wheat flour is exceptionally attractive to food manufacturers because it is neutral in flavor, light in color, and highly responsive to additives. Its gluten proteins form elastic networks that can be stretched, shaped, and engineered to produce everything from airy sandwich bread to chewy noodles and flaky pastries. This flexibility allows manufacturers to design textures that feel comforting, indulgent, or addictive, depending on the product. Because the natural nutrients have been removed, the flour also acts as a blank canvas that can absorb sugars, refined oils, flavorings, and colorings without interference from fiber or natural fats that might limit shelf life. Another reason wheat-based foods so easily become ultra-processed is the speed at which refined flour is digested. Without bran and germ, starch is rapidly broken down into glucose, creating a quick energy spike. To make these products more appealing and to mask their nutritional emptiness, manufacturers often add sugar, malt extracts, or high-glycemic syrups, further increasing their palatability. Emulsifiers, dough conditioners, and enzymes are then added to improve softness, volume, and consistency, ensuring the product stays appealing for weeks or even months on store shelves. These additions are not accidental. They are carefully selected to optimize mouthfeel, appearance, and repeat consumption. Wheat flour also performs extremely well under industrial processing methods such as extrusion, deep frying, and high-temperature baking. These processes allow companies to produce massive volumes of food quickly and cheaply, turning simple flour into crackers, breakfast cereals, instant noodles, snack cakes, and packaged breads. Because refined flour absorbs water easily and gelatinizes predictably, it shortens cooking times and reduces production costs. This makes wheat-based ultra-processed foods some of the most affordable and accessible calories in the modern food environment, which partly explains their global dominance. Despite these concerns, it is important to maintain a positive and balanced perspective. Wheat itself is not inherently problematic, nor is processing automatically harmful. The issue lies in how far the processing goes and what is added afterward. Whole wheat flour, stone ground flour, and traditionally fermented breads retain more of wheat's original structure and nutritional complexity. Fermentation, in particular, can improve mineral absorption, reduce anti-nutrients, and make wheat easier to digest for some individuals. These traditional methods demonstrate that wheat can still function as a supportive staple rather than a metabolic stressor. In a broader context, wheat's tendency to become ultra-processed reflects modern food priorities rather than the grain's intrinsic nature. Its adaptability, long shelf life, and functional proteins make it invaluable to industrial food systems focused on efficiency and profit. At the same time, These same qualities allow wheat to nourish populations when handled with care and respect for its biological structure. Understanding why wheat so easily becomes the foundation of ultra-processed foods empowers consumers to make more intentional choices, favoring forms of wheat that preserve fiber, micronutrients, and natural fermentation, while still enjoying the cultural and culinary benefits this ancient grain has provided for thousands of years.